Venus is a planet of extremes, a world where the surface is hot enough to melt lead, the air pressure would crush you in seconds, and the atmosphere is thick with sulfuric acid clouds. And yet, Venus is also our closest planetary neighbor, remarkably similar to Earth in size and composition, the only other Earth-like planet we may ever be able to study up close. Although Venus is seemingly uninhabitable today, scientists think it may not have always been that way. Studies suggest that Venus could have had liquid water on its surface for as long as 2 billion years, a duration far longer than Mars, which only held water for around 300 million years. Understanding why Venus experienced such a dramatic shift in climate could reveal clues about the Earth's potential future and what makes our planet so unique in sustaining life. Venus can also teach us about planets beyond our solar system. Many of the exoplanets discovered orbiting distant stars have atmospheres and sizes similar to Venus. By studying Venus, we could gain new insights into these distant worlds and the factors that make a planet habitable. But up until now, most of what we know about Venus comes from a series of short-lived Soviet landings on the planet. The probes launched in the 70s and 80s, and many of them successfully reached the surface of Venus, but none of them operated for more than a few minutes before succumbing to the harsh environment. NASA made their own investigation of our sister planet in the early 90s with the Magellan orbiter. It successfully imaged the entire surface of Venus for the first time, but the technology available 3 decades ago wasn't able to provide the deep understanding of Venus that modern scientists are after. With this in mind, 3 major space agencies of the 21st century, India, Europe, and the USA, are gearing up for a new era of Venus exploration. Together, these missions promise to unravel Venus's mysteries, creating a comprehensive picture of a planet that has eluded us for so long. India's Venus Orbiter mission, or VOM, is set to launch in March 2028, marking ISRO's first mission dedicated to Venus. Unlike India's first interplanetary orbiter mission to Mars, which was mostly just a technology demonstration, VOM is a full scientific mission equipped to provide substantial insights into Venus's surface, atmosphere, and volcanic activity. India's most powerful rocket, LVM-3, will send the probe on a journey of approximately 112 days, with VO arriving at Venus in July 2028. Once there, it will enter a highly elliptical orbit that dips as close as 500 kilometers to the surface and extends as far as 60,000 kilometers. Using a technique called aerobraking, where the spacecraft gradually slows down by skimming through the planet's upper atmosphere, VO will eventually achieve a stable lower orbit ideal for scientific study. VO will carry over a dozen advanced instruments, such as the Venus Synthetic Aperture Radar. This radar will map the surface at high resolution, capturing features as small as 20 to 30 meters across. It will allow scientists to see through the thick clouds and observe mountains, valleys, and volcanic features. The Venus Surface and Atmospheric Mapper will study the composition of the planet's atmosphere, mapping volcanic hotspots and identifying any trace amounts of water vapor. The Subsurface Sounder will be the first radar to peer below Venus's rocky crust, possibly revealing ancient impact craters or hidden basins that could tell us about the planet's early history. The Hyperspectral Infrared Imager, by looking through specific wavelengths in the infrared spectrum, will identify volcanic hotspots and potentially active lava flows. With these tools, VO will help scientists piece together a clear picture of Venus's geological history and the processes that shaped it. Discovering active volcanoes, for example, could explain how Venus maintained such a thick atmosphere. And if certain rocks contain minerals that only form in the presence of water, it could confirm that Venus once had oceans, challenging our understanding of how Earth-like planets evolve. On the other hand, we have ESA's Envision mission, scheduled for launch in the early 2030s. It aims to take Venus research to the next level by studying both the planet's surface and investigating deep down to its inner layers. With advanced radar and spectrometers, Envision will look deeper into the planet than previous missions, investigating the geology, atmosphere, and volcanic activity on Venus. This mission will follow a trajectory similar to India's VOM, but once in orbit, Envision will focus on some unique areas of study. Envision's payload includes several specialized tools designed to delve into Venus's surface and interior processes, such as the Synthetic Aperture Radar. Similar to VOM's radar, Envision's will map the surface at a different wavelength, capturing highly detailed images that reveal the shape and structure of the planet's landscape. This radar is particularly effective at detecting tectonic and volcanic features. The infrared and ultraviolet spectrometers are designed to detect chemical signatures in the atmosphere and on the surface. They'll examine cloud layers, looking for signs of volcanic gases like sulfur dioxide. Since some parts of Venus's atmosphere allow infrared light to escape, the infrared spectrometer will also be able to detect minerals and surface rock compositions. The ground-penetrating radar will operate in tandem with the SAR. This tool will see beneath the surface to analyze the planet's internal structure. It will look for subsurface features like buried impact basins, providing clues about ancient impacts that could have shaped Venus's surface. Envision's high-resolution radar and spectrometers will build on the data collected by previous missions, including India's VOM. By studying the chemical composition of Venus's surface rocks and searching for active volcanic gases, Envision could answer key questions about the planet's climate history and volcanic activity. If Envision finds the surface has been reshaped recently by volcanic or tectonic activity, it will suggest that Venus is still geologically active. This would fundamentally change our understanding of the planet, showing that even without tectonic plates, Venus has internal processes similar to Earth's. These findings could also reveal if Venus ever had enough water to support life. NASA's Da Vinci, or Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging mission, is a highly anticipated project aimed at studying the thick Venusian atmosphere up close. Unlike VOM and Envision, which will orbit the planet, Da Vinci is designed to dive straight down toward the surface, making it the first probe since the 1980s to directly sample Venus's thick clouds. Expected to launch in 2029, Da Vinci will take about 6 months to reach Venus, where it will release a spherical descent probe packed with advanced scientific instruments. DAVINCI's probe is loaded with tools specifically designed to handle the intense conditions of Venus's atmosphere. Its mass spectrometer tool will measure the composition of gases in Venus's atmosphere, focusing on noble gases like argon and xenon. By studying these gases, scientists hope to understand how Venus's atmosphere formed and evolved over billions of years. The tunable laser spectrometer instrument will look for specific gases such as water vapor and carbon dioxide, which could provide insights into past volcanic activity. It will also search for the presence of phosphine, a gas that is known to be produced by biological life in low-oxygen environments. During its descent, DAVINCI's cameras will capture high-resolution images of Venus's surface, offering unprecedented views of features like mountains, valleys, and ancient river channels. As Da Vinci descends through Venus's atmosphere, it will collect data on temperature, pressure, and gas composition in real time. These measurements will allow scientists to study the planet's atmosphere layer by layer, helping to reveal how the climate evolved to become so extreme. The mass spectrometer's analysis of noble gases will provide clues about how Venus lost its water, while the laser spectrometer's search for phosphine could reignite the debate over the potential for life in the Venusian atmosphere. Together, DAVINCI's observations will fill in critical gaps in our understanding of Venus, complementing the data collected by VOM and Envision. The missions led by India, ESA, and NASA are designed to work together, creating a multidimensional understanding of Venus. Each mission has its own unique approach. VOM will map the surface and atmosphere from orbit, Envision will investigate deeper into Venus's crust and atmosphere, and Da Vinci will dive directly into the clouds, sampling Venus's atmosphere firsthand. Together, these missions will give scientists a comprehensive picture of Venus, from its fiery surface to the acidic clouds that swirl far above. The data collected by these missions will allow scientists to compare different observations across the same regions. For example, VOM and Envision's radar images of Venus's surface can be used together to create high-resolution 3D maps. Meanwhile, DAVINCI's atmospheric readings will give context to Envision and VOM's observations of cloud structure and chemical composition. This coordinated approach will reveal Venus's past and present as no single mission could, showing us how planets evolve, why they become habitable or hostile, and what conditions are necessary to support life. Understanding the evolution of Venus could provide a blueprint for predicting Earth's future. Venus's extreme greenhouse effect, fueled by carbon dioxide, serves as a warning of what could happen if a planet's climate spirals out of control. This research could also help scientists better understand exoplanets, planets orbiting other stars with characteristics similar to Venus or Earth. As scientists discover more Earth-sized exoplanets with dense atmospheres, the findings from Venus may redefine how we understand habitability in the galaxy. The Venus Orbiter mission, Envision, and Da Vinci represent a global effort to unlock Venus's secrets, providing essential insights into how planets, including Earth, change over time. Thank you to Jitan for his contributions in today's script. To learn more about the Venus missions and other space initiatives,